we have done electrical fields and magnetic fields. What was the appropriate property for an object to experience an electrical field? So the field's there, what does the item have to have before it can respond to that field? You answered last time, somebody else has to answer this one. I know you know it.
What was the question?
It was like, come again? What is the appropriate property that something has to have before it will experience the electrical field that it like if it's in that field, if it's close enough, what does it have to actually experience that? Zach? Kind of. I mean, that's what's kind of creating the field. 9? Nope.
Wait.
You guys are just throwing out random words now.
Donald Trump.
Wait, is it?
A charge! A charge! Right? So a charge, what is a charge?
Something? Oh, you plug your phone in and it charges.
Uneven amount of
Protons.
protons and electrons. Good. I don't know why, but charge is the hardest one for people to remember, right? That is the appropriate property. So like with our fart funk, it's not going away, right? The fart funk, the appropriate property that you would have to have is smell, right? So let's say somebody would get COVID and one of the symptoms occasionally can be where you lose your sense of smell. Everybody else could be like, oh man, you're like walking into the fart funk, it's terrible, it's awful, eyes watering, gagging, crying. Somebody that has temporarily lost their sense of smell would not have the appropriate property to be affected by that fart funk. They don't have the appropriate property. The fart funk is still there. Everybody else is experiencing it, but they don't have that appropriate property. So if something has equal protons, Zach and Aiden, if something has equal protons and electrons, it's not going to experience that electrical field because it's not charged. Okay? What was the appropriate, this was much easier, appropriate property for magnetic fields?
Wait. Nope.
Has to be magnetic. It can't be like my plastic, right? It has to be a metal that it has properties of magnetism. Okay? So we are going to move into our third type of non-contact force, and these are the forces that create gravitational fields. And so gravitational fields exist around objects with mass, which is why maybe a few of you were shouting out mass, weight, and you're trying to tell me electrical appropriate properties. So if you take a second object that also has mass and place it within that field, it's close enough to the field to experience it, and both objects have mass, one of them will attract, with a gravitational force, the other object to it. Yes?
Does anything with mass, like no matter the mass, have a gravitational field, or does it have to have a certain
So here's the thing, everything does. We are all exerting a gravitational pull on each other right now, everything in this room, but you also have a key point in there. There is a certain, it's not like you reach a certain number and it's like, oh yeah, that's the special number. What it is that you don't experience it, like it's not big enough to really even notice unless one of the objects is massive. We're talking planetary massive, not just like big like an elephant or big like a mountain. We are talking big like a planet or like our moon, right? We're talking something that large. So extreme mass is needed. Okay, so everything is experiencing and giving off some gravitational pull. But obviously it's not like, whoo, I'm being sucked to Abby right now, or Shelby's being stuck to my phone, or vice versa, right? Everything is putting off some gravitational field and experiencing a pull of gravitational field from everything around. But do we notice it? No, not at all, right? What are we experiencing right now in this room? What force are we experiencing? What gravitational pull?
I was just gonna say gravity.
Oh, but what's the item that is kind of the biggest force of gravity that we're feeling right now,
Use
Nye?
your brain.
Yeah, I have a question.
Oh, okay.
Use your brain.
Back here, we are basically the size of a planet. Would we be attracting bacteria?
Still not big enough. Dang, good thought though, good thought. Now, would the bacteria feel the pull more from the bacteria to you than maybe you to Zach? Absolutely, because you guys are similar in mass, right? So obviously there'd be a little bit more of a pull, but is it enough where you're gonna be attracting every bacteria around? No, which is a good thing, right? Zach?
I had the answer to the question, then I forgot it. I mean, I forgot what the question was. I forgot the entire question.
I do too now.
What, like,
It
experience
was
are we
like-
forced?
Oh, yeah.
Gravity.
What, I know we're all experiencing gravity, but what object?
Earth. That's what it was.
Yeah, Earth, right?
That was-
We're being pulled to Earth, and you can see with these arrows, these gravitational field lines, we're being pulled to the object, of the greatest mass, and that is the planet Earth that we are now on. And so we are being pulled towards that center of that massive object. And so Earth, not only has a gravitational pull on us, keeping us on its surface, but it also has a gravitational pull on the moon, which is why the moon is part of, it's in our orbit, right? And so just like every other force field, the gravitational forces are gonna weaken as you move away from the object. So as we move away from planet Earth, we leave its orbit and we are far enough away that we are no longer being pulled to it like you would if you're within that gravitational field. Just like my magnetic board. Again, it's the most easy one to see, right? If I'm far enough away, that field of magnetism is still there, but it's not attracting my magnet. I have to get close enough to experience that. So that's gonna kind of be where we start off with tomorrow. So make sure you bring your correct folders, some of you.
If we